Hello there. Okay, we got a new project. This one is a ultrasound, okay, sensor. It's an ACRS, and we have a servo. Okay, it's a 180-degree servo, and what it does this is scanning for any movement, any object close to it. Set up a threshold of 30 degrees. So if any like this, the LED red goes on and it stops. You remove and it carries on, and it spins 45 degree, 90 degree from left to right, which is 135 degree minus 45 will give you 90 degree. So those are the threshold of the angular momentum, whatever you want to call it. Okay, so this is the way it works, and I have put the this is the pin, the servo. It's on pin number 18. The LED is on pin number 10. Okay, and then I have the you see the trigger. It's on pin number 3, and 4th is the echo. Okay, so that's where it stops. Carry on. Stop. Carry on. Let us see this other side. It's going to stop now because it picks up the tripod of the camera, which is too close. Stops. Okay, pick up from distance as well. Putting my hand 300 centimeters. See? Yeah. Obviously it picks up big object. If the object are small, the LED will flash. I mean, the fly can, fly close to the ultra sensors. It will show the LED on. Okay, so this is the way it works. The LED, as I said, it's like all the other project. The LED has a resistor, 220 ohm. The shorter leg is grounded with a resistor, and the longer leg is with the number 10, pin number 10, which is carried forward here, as you see, it brings it out. So, and then what I did here, I ground this side because I've got the LED, and this side here has got all the rest. So I made a railing here, and this railing is transported to the ground on this side, and not 5 volt because I don't need it for the moment. Okay, so this is the way it works. The LED stays on, LED goes off. Okay, simple. Let's see the card. Alright, so what we got here, it's my one, you must remember, let me show you something quickly. My, okay, this is, my one is a ESP32C3. So they have a different pin number allocated from any other different type of ESP32. So I'm going to put this one here just for you to see that the pin numbers, these pin numbers are correct to my pin numbers of the ESP32C3 that it is. Okay, so this is the way it is, and so let's go back to the card so you don't get confused if you got another another ESP32. The pin numbers are not correct, so there was the map. Alright, so we only need one server because it's the ESP32. I'm using ESP32 Servo .H, okay? So that's for, I don't know what kind of ESP. There are different type of ESP. Let me see. I can, ESP32 Servo, let's see. You see there is ESP32 Servo, there is ESP32-S Servo, ESP32E controller. Okay, so, and you know, so it's up to you. I'm not sure which one you have, but yeah. Okay, it does work. So here we define a trigger pin, which is pin 2, echo pin, which is pin 3 of the ultrasound sensor. Then we have the servo, which is on pin 18. Now, the problem with the pins are they have a different noise, electrical noise, because it's ESP32, and I'm not using analog, obviously. But the pin always is based on the particularly for the servo, it's based on the PWM. So some pin have a different frequency, and that might affect your performance. I found in my case, I've tried several, but pin 18 seems to work fine. Okay, so that's my experience. I'm not sure about your side. Okay, so here's a servo, my servo, and this is to a range of servo motion, which goes between 40. It's left, move left and move right. It's 45 degree minus 35, and it's 90 degree. The reason why this is because it's 180 degree rotor servo. So you gotta give it a full extension, and you minus it in order to achieve the 90 degree. Then you have, there it is, it's 40 scan and 135, scan start at 45. Then you have the step. The smaller step is smoother and the higher step is stuttering. Then you have delay per stop, which is 100, in this case, smooth movement. Okay, you move, yeah, you can bring it up and it's sort of, it's not stuttering, it's moving smoother and smoother, because obviously there is also a lot of noise pollution, electrical pollution. Okay, so float, this is a threshold, it's 30 degree, sorry, 30 centimeter, it's a distance. So what happened at, it'll stop at 30 centimeter, it'll pick up any object at 30 centimeter, it'll stop. Release, see, and it goes. So what it does, it's, you know, well, you can change this one, okay? You can actually adjust all these parameters, 45, 135, 2, and 100, you can, and 30. The distance can also be adjusted. You can put 400, whatever you wish. All right, so here we go through all the codes. And the my servos, the angulation, and here is, okay, so this is, you know, practically you have, if, you know, the distance is less than 30 centimeter, it stops scanning. And if the distance is above 35 centimeter, it reassumes scanning. Okay, so you can see here bigger than and smaller than plus. There we are. So this is to adjust the movement left or right. Okay, so, and there it is. I put some information here. If no object is found nearby the servo, we'll enter scan mode and slowly sweeping left and right. Okay, if there is no object on 30 centimeter. So the servo angle is incremented or decremented based on the scan step. And this, as I said, you can change it as well. So there it is, the angle scan. If the servo hits the scan range limit, it automatically goes back. So this is to control the distance between 135 and sorry, it was 135 and minus 45, which is 90. Okay, so here we are. I'm not going to go with more. Everything is covered. The most important one for you is if you want to adjust this parameter. Okay, and you can try and error and try how you want it. Okay, so this is still working and scanning. Stop. Okay, now let me see, I'm at 300 centimeter. Yeah. LED goes on. What you can do as well, you can put not only the LED, but you can put an OLED screen, which I'll do it later. I thought to do something silly. You could put a laser on the side, so that it looks like a cowboy. You have a laser, and the laser goes on every time he picks up something, he shoots, and then you put a buzzer, and you have a Star Wars noise, like a shooting, you know, chung, chung. That can make fun. Yeah. Okay, I think we covered everything. Yeah, remember this one. This is important because this is the pin of my GPS. GPS, sorry. My ESP32C3. Okay, so let's go back to the scene. Alright guys, hope you have a good Monday. Thank you very much. I hope you like it, and please give me a thumbs up.